In the last lecture, we had covered some fundamental aspects of the environment. In this lecture, we will take a closer look about the pollutants that are involved in this study. So, when we call something as a pollutant, so in our discussion, we will give it this nomenclature A. So, A can be anything. So, what is a pollutant? So, in this context, we are talking about toxicology, which means there is a material, there is a substance. A is a substance, any substance. Okay. So, what are the possible classifications of this substance that you can think of? So, what broad classifications can you think of for any substance? It's important only from the point of view of classification. There is no other importance to this other than that you can group one set of things, and because a lot of things will change, what we discuss subsequently will change based on this. So, no, I am talking about properties of the chemicals. In a sense, basic properties. Toxic, non-toxic is a much more refined classification, and that's. No, in general, when you go to chemistry, what is your most fundamental classification? More general classification based on that? No, I want a little more general classification. What kind of branches of chemistry exist? Organic and inorganic. That is one classification that can be made. Organic and inorganic. Yeah. In organic chemicals, what can you make further classifications in organic chemicals? From a point of view of chemistry, aromatic, aliphatic, and those kind of things. So, aliphatic includes single bonded, double bonded, triple bonded compounds for carbon chains, carbon things like alkanes, aliphatic are things like alkanes, alkynes, and so on. Then you have aromatics. So, alkanes, you have a general compound. For example, you can have C, a compound which looks like this, okay, which and so on. This is an example of an aliphatic compound. But you can also have a compound that, for example, I can have C, single compound. So, for example, if I have methane, for example, I can also remove one methane and put a chlorine. I can remove two methanes and put two hydrogens and put two chlorines. Okay. These compounds are derivatives of aliphatic compounds. So, for example, this is dichloromethane. You can have CCl3 or CHCl3, which is chloroform, and then CCl4. These are all compounds of interest in. These are all compounds of interest in the in application in environmental sciences. So we have aliphatic and aromatic. We have derivatives of aliphatic compounds. Then we have aromatic, which is aromatic by definition is anything that has a benzene or a phenyl compound. So, this is simple, this is benzene. So, here you can have multiple rings, 2 rings, and you can have 3 and so on, you can keep going. So, these are simple aromatic there are compounds, aromatic compounds. For say benzene itself, I can again substitute one hydrogen with chlorine, or I can have some other compound like a hydroxyl group or I can have another compound with I can have benzene here or any other bromine, whatever I want, and anything else here. So, I can have CH3 and so on. So, these kind of possibilities exist. So, these are all derivatives again. I can have NO3, I can have multiple chlorine. So, several possibilities exist here again. So there are derivatives, there are aliphatic compounds, there are derivatives of aliphatic compounds, there are aromatic compounds, and there are derivatives of aromatic compounds. These are all possible. This list here, so if you are talking about these compounds are polyaromatic hydrocarbons. There are multiple aromatic rings here. So, for example, this is naphthalene. So, this is naphthalene. This is naphthalene, and this is phenanthrene or anthracene. This is one of the two isomers. Okay. So, there is another class which is called as polyaromatic hydrocarbons. Then among the other derivatives of polyaromatic hydrocarbons, you also have a class of compounds which look like this. Okay, there are two phenyl rings, and you can have multiple chlorines associated with this. Okay. This is one. So, these are all, these are biphenyls. I think a structure, I do not know if it is, yeah, it is biphenyls. The biphenyls here, and this is polychlorinated. So, chlorine is a very important compound. From applications, one of the applications of chlorine that in your common daily usage is for disinfection, which means that it is used for killing microbes to make water safer to drink and all that. So, by that function, chlorine is a oxidizing agent. It is a very strong oxidizing. It will do, it makes things cleaner. So, it is also at the same count, if you ingest it, it is not very safe for the human body also. So, chlorine is not a very safe thing in general. So, anything that has chlorine attached to as a derivative, it has a lot of nice properties in industry, but the same things also are harmful to us. So, whatever compound has been synthesized, people have synthesized several compounds based on whatever fundamental materials you can get to make products that have certain chemical properties which are useful in some products. But at that point in time, we do not realize what can it do if exposed, if human beings are exposed to it. Okay. So, it's not an easy question to answer and discuss. We will get to that in a little bit and the repercussions of that. So, wherever there is chlorine, it is considered as it is flagged, it is marked as a little bit hazardous, more hazardous than this. So, if you just have methane is nothing, we do not have a big toxicity, but you add one chlorine or two chlorines, the toxicity changes significantly. So, this is one. So, polyaromatic hydrocarbons, then we have this class polychlorinated biphenyls or PCBs. So, PCBs, and there are other derivatives of this compound. There is one compound which has an O in between and all that. So, we will I will let you do, I will have an assignment for this where you can look at the structure and other properties of this group of chemicals. So, here we have some very crude broad description of this thing. So, where we have inorganic chemicals, we can have aliphatic and derivatives, then we have aromatic and derivatives, and then we can extend this, we make another this thing as we can have polyaromatic hydrocarbons or polychlorinated biphenyls. Here are some of the chemicals that are listed. This kind of covers the, you can make it as complicated as you want. You can have a long chain aliphatic, long chain aromatic, all kinds of possibilities exist in this, and the derivative part covers everything. Okay, but you have another type of classification that people also use in very specifically, which is application based. So this is based on structure, chemical structure and composition, but application based from a utility point of view, you can also classify the chemicals of your interest, of chemicals of concern. So one of the things we are looking at, these are all what we call as chemicals of concern. There are thousands more lakhs of compounds available to us. We are concerned about some of them, we are not concerned with all of them. So these are chemicals of concern. So anything can become a chemical of concern if there is evidence for us to believe that it can cause human health problems, and then we need to track it, this thing. So application based chemicals of concern, they are all the same compounds. Okay, they are nothing different from what we are. It is not a separate compound, but application based classification. So what would you suggest application based classification? Which means there are chemicals that are used for a specific application. So what kind of applications can you think of? Huh? Anything, industrial, domestic, whatever. Can you be more specific in agricultural? Okay, disinfectants, can you expand that? Disinfectants, what kind of disinfectants? So disinfectant is, you are talking about water disinfectants or any any other kind of in the same class as disinfectant. Disinfectant has a very limited definition. It's used for water treatment and all that, but is there a larger application of chemicals that you can think of, any application? Where are chemicals used? So then we will classify. There are large industries which use this. The magnitude of fertilizers. We put it there. Anything else related to agriculture? Pesticides. Yeah. Yeah, pesticides and insecticides. Yeah. Any other class of chemicals? Application based. Paints. So what is used in paints? You see advertisements about paints and all that. So people advertise that paints are something free. Yeah, lead is there, but that's a good point. Lead, other things are also there in paints. What's the main thing that people advertise? What is in the paint? Yeah, but what is the VOCs? VOCs are, you're right. VOC is a classification. We will come to that. So what is a big class of chemicals that is used in industry a lot, including paints? Huh? No. So when you paint, normally you have a suspension, right? But when you apply a suspension, what needs to happen? Yeah, there is a paint that sits on the wall, but it is wet and it becomes dry. So what is the difference? Why does it become dry? It has a volatile compound. What is that volatile? Why do you have a volatile compound in there? What is the purpose of the compound? Any other major applications in industry which chemicals are used in? Are you familiar with that? Huh? Adhesives, okay. So even in adhesives, the same thing, pharmaceuticals. But I am trying to get to a particular application, I think. related to paints, coatings, thin films, paints, all of them have one particular component which people have tried to replace over a period of time. Yeah? It is solvents. People use solvents for various applications. Solvents means they will dissolve all the things, they will bring it into a solution or suspension, and then you can apply it wherever you want, and you have to get rid of the solvent. That the solvent, the easy way of getting rid of some, for example, if you paint, you want the paint to be dry fast enough, which means the solvent has to evaporate. When it evaporates, it's volatilizing, it is in the air, and that is the VOC that was mentioned. We have not come to the term VOC yet, but we have heard it in public media and all that. Solvent is a big this thing. So, solvent essentially the property of a solvent is that it must be able to have high solubility for a lot of materials that you are working with. So, you must keep them bound and all that. So, and also solvents are also used for cleaning. So, in processing industry, people clean several components of this thing. So, they use solvents to clean. So, you want surfaces to be clean, they use a solvent. And we use solvents for a lot of things, okay, in very specialized industry and in bulk industry, in factories and all that. And we also use a lot of solvents in semiconductor industry and all that. So, all kind of industries use solvents, that is there. Anything else? Pharmaceuticals is one big class of chemicals, a lot of pharmaceuticals. Any other applications based? Textile, textiles, dyes, petrochemicals. Anything before petrochemicals? Before petrochemicals. Petrochemicals are what? They are chemicals derived from petroleum. There is the petrochemicals slash this petroleum based products themselves, petroleum itself is a matter of concern, because petroleum is a mixture of lot of compounds. You do not know what is there in it, depending on where it is coming from, it may have a bunch of things. And when you have when this is a process, petrochemicals is when you make a particular fuel or something, you will add certain things to make it work in an engine. So, you have additives in it. So, there are additives that are put into this which make it more functional for whatever application you are using. So, these are some of the big classifications, you can think of many more, okay. So, the solvents include a wide range of things, anything, water is a solvent, but water is not considered as a hazardous thing, but there are other solvents which people can use. Acid is a solvent, yeah, and there are a lot of organic solvents in here. So, okay. Now, we go to the other class of inorganic compounds. So, if you look at the application based things we have looked at on the left hand side here, we have disinfectants, fertilizers, pesticides, paints, pharmaceuticals, textile dyes. A large number of these are organic compounds. If you go and look at the structure of many of these things, they are all organic compounds, and they fall under the classification that we have given here. So, this classification that we have all looked at, these classifications they will correspond to these classifications very easily. So, inorganic compounds, if we are looking at inorganic compounds, can you give me examples of inorganic compounds that are of concern very quickly? That does not contain salt of what? What do you have in a salt? What is the definition of salt? Somebody said salt. If you do not know anything about the inorganic chemistry, simply when you say inorganic, it is something that does not have carbon, that is the broad definition. Carbon may be there in some form, but it is not classified as the organic part. What can you think of as inorganic compounds? Heavy metals. So, in general all metals, any metals
is inorganic. So, we have elements. So, what we will generally classify them as elements. So, elements are anything. So, we have sodium, potassium, calcium, iron, so on, magnesium, manganese, aluminum. And we have classification things like lead, we have arsenic, we have chromium, we have selenium, we have tin, we have zinc, and we have mercury, and so on. So, there are elements. So, these elements are fundamental entities, but these are usually, some of them sometimes they are found as elements as this themselves, but they are also found sometimes as ions bound with something else. So, they are formed in the form of a compound. We have sodium, we have iron. So, if you take the case of iron for example, so you can have iron as 2 plus, iron as 3 plus. And this is called as the ionic state can have different what we call as oxidation states. Or valencies. Oxidation state is a more generic term. So, depending on the oxidation state, it will bind with different other things to form another compound. Okay. So, that compound whatever is formed, it may be more stable in the environment or less stable in the environment, may be soluble, may be insoluble and so on. So, these kind of things depend on the oxidation state of the chemical. And so, it is a little more complicated. So, here what we are doing here, for example, if you take case of mercury, mercury is a very well known toxic compound element. Mercury is found as Hg0. Hg0 when we say is the elemental form of any mineral. So, it is not attached to anything, it is present as mercury itself. But you can also have mercury 1 and mercury 2 plus. Yeah, and it binds with different things. Mercury will bind with different things. Okay. So, this is a form of, typically an element is present as elemental form, which is, if it is this is elemental mercury, or it is present in the form of some other compound, there is a salt usually, or an oxide. Okay. So, all these elements usually you will find it in the form of a salt or an oxide, depending on where it is formed, where do you have it. People have also made compounds, synthesized compounds to have multiple elements in one compound for a particular application. So, this is sometimes they are very specialized things. So, it may or may not be important depending on where it is being used. The only compound is used, see application based this thing we saw that we have a large number of applications, but if there is only one small application, somebody in one factory is using it only for that this thing, chances are it may not be widespread. So, that sometimes they make a very specialty compound for one particular application and it is very small and people may not know about it at all. Okay. So, this is a very expansive. So, you look at this list, if I want to find out what is there in the environment, it is a huge task, right. I can have potentially even from this list itself, I can have potentially I can have a large number of, I can go across this entire class of compounds. I have to do some way of even to find out what is there, it is very hard. The analysis of any of these compounds to find out, if somebody comes and asks a question, I give you a water sample, please tell me what is there in the water sample. Any of these could be there in the water sample, technically, right. I cannot, so I have a problem because I have to spend a lot of money and energy and time in order to find out what else is there, all of this is there, and then we have also this entire range of compounds here. So, is there a way in which I can, then it becomes a matter of engineering decision making, that I have to spend my money and resources and time where I can guess whether which of these is likely to be there. I also need a ranking. I need to be able to prioritize whether something is there or not. If I am looking for a particular compound, and if that's not, likelihood of that not being there is high, then I do not have to spend my time looking for that. Okay. So, I must have some rational reason why I am looking for a particular compound. Okay. This will link into our next topic in the next section of monitoring and analysis. I have to make decisions of which one to monitor, which one to measure, because it costs money to do all of these things. It is all linked back to that. If I have infinite resources, I have 100 people working on one sample, I can do everything in the world. Unfortunately, we are not in that scenario. We have to make decisions in which we rank things, and then the highest, most this thing gets the priorities.